Good morning, everyone. I am Shivam Kumar, pursuing BTech CSC in Leveling Professional University, and today I am here to explain you all the implementation of stack using list. So, definition of stack. A stack is a fundamental data structure that follows the last in first out LIFO principle, meaning the last element added to the stack is the first one to be removed. Think of it like a stack of a plate. We can only remove the top plate, and the last plate we put on the stack will be the first one we take off, we inserted first plate, then the second one, then the third one. So if we can only remove the top plate, then the third plate. If we want to remove the plate, we can only remove the third plate. And if we want to add the another plate like the fourth plate, we can add on the top. Means we can add or remove only on the top of the stack. Another example of the stack, like imagine we have a stack of book on our desk. Every time we get a new book, we place it on the top of the stack. When we want to read a book, we take the one from the top of the stack. We can only add or remove books from the top of the stack, not from the middle of the or bottom. Like we have the book first, second, and third. If we want to read a book, we'll take the third book, means the top of the book. Or we want to add another book, we will add on the top of the third book. Like when we want to read a book, we'll take the one from the top of the stack and we can only add or remove from the top of the stack, not from the middle, like not the second or the first one. Now the operations of the stack. The first in push. Push meaning adding an element to the top of the stack. Like in earlier example, we added fourth book on the top of the third book. Next, in this diagram, we have a stack with four elements 4, 7, 2, and 5. The top of the stack is the rightmost element, which is 5. Means the top of the element which we have in a stack is 5. Next, if we want to perform a push 9, the stack will become. Means we want to add 9 in the stack of the top. What will be the output? See, 4, 7, 2, 5, and 9. We have added 9 to the top of the fifth element. Next operation of the stack is pop. Pop means removing the top item from the stack. Like the last element that we added, 9, if we want to remove it. So if we want to perform, we will remove the top element 9. So after removing the element will become 4, 7, 2, and 5. See, we have removed this 9 top element from it. Next operation is peak. Peak or the top. Viewing the top element of the stack will without removing it. Like we have this diagram 4, 7, 2, and 5. If we want to see this top element, we can easily see it without removing it. If we want to perform a P function, we will see the top element 5 without removing it. Fourth one, empty stack. Checking if the stack is empty or not. Like we have this stack, it will check is it empty or not. Size, checking the number of the item in the particular stack. How many items are in a stack? Like in this stack, we have 1, 2, 3, and 4 items. The size of this particular stack is 4. Like we have 1 plate, 2 plate, and 3 plate, 3. How many? The size of the stack will become 3. Now we have the basic knowledge of all the operations of the stack. Now we will implement these operations of the stack on a code. So now let's let's write the code now. So first we will take the class name stack. Then we'll define the init function. self dot items. We'll take the item empty. Then defining the first function, that is empty. Define is is empty. Self, it will return the value when self dot item equals to 0. Then defining the next function, that is push function. Self dot items dot append. Push meaning adding a function, so we'll append it. Now the next function, pop. So we will define pop. In pop function, we'll apply filter if and else clause. If self dot is empty, if the item is empty, then it will return. If it is not empty, it will return self dot item dot pop. Else raise index error pop from an empty stack. Then the next, we will define peek function. Peek, what is a peek? Viewing the top element. So if the top element is not empty, it will peek. It will show the top function. So if not self is empty, return self dot items -1. Else raise index peek from an empty stack. Then we will define the size of the function. Size self return length of the self dot items. So we have defined all the function. Now let's take the items of the stack. Stack equals stack. First, we want to add an item to the stack, so we will use push function. Push one, we have added one. Again, stack dot pushed. Second, stack dot push. Third, then output print stack size comma stack dot for the size of stack. Then print the top element. For the top element, what we will peek use peek function to see the top element. So we have got the top element. So now let's remove the elements from the stack. For removing the element, we will use the pop function. But we want to remove the all the elements one by one. So for it, we will use a while function. So while not we are using because if the stack is empty, we can't remove any element. So first, the stack dot is empty. Then popped item goes to stack dot pop. Then print the value, print popped item popped item. So now print will print is the stack is empty. Is the stack empty now? We'll use an empty function. Stack dot is the empty. So we have written the code now. So let's get the output. So what will be the output? First we are printing the size of the stack. So what is the size of the stack? We have elements 1, 2 and 3. So the output will become the size of the stack 3. Print top element of the stack. So top element, what is the top element? The top element is 3, the last element that we have the added. So this is the top element. So we have removing, after removing all the stack, we have removed 2, 3 and 1. So is the stack empty now? So as we have removed all the elements, so the stack is empty. So it will become the value true. So now let's run the code. So see, we have got the output as I earlier told you. The stack size is 3 as we have the element 1, 2 and 3. 3 elements we have. The stack size is 3. Top element 3. We have the top element 3 here. And the popped item. First we have removed the item 3, then 2, then the 1. So as we have removed all the items from the stack, now the stack is empty. Is the stack empty now? It's true. It's giving the value true as the stack is empty. So this is the implementation of the stack using the list. I hope you all have understood it. So thank you guys for watching my video.